1/4 and theta has its terminal side in first quadrant, find the exact value of sine of 2 times theta. Well, if I look at this problem here, you're not going to do something silly like multiplying this number times 2 because you just see 2 there. This is called the double angle identity of sine. Located on your formula sheet. Partner B, tell partner A, what is it? Jason?
Sine 2a equals 2 times a cosine a?
2 times sine of theta cosine of theta. That is called the double angle identity. Double angle identity. Okay, so we have sine of theta is 1/4. So I can put that in there. So I have 2 times 1/4. Uh-oh. We don't have what? Cosine. Okay. Take 25 seconds with your partner. You need to think of an identity that can help you find cosine given sine. Ready, set, go. Look at that formula sheet. Nicole. Okay, she said the cofunction. Let's take a look at the cofunction. Cofunction identity is if you have an angle. For example, if I say cosine of 45, that means 45 degrees. Then you would do something like 90 minus 45, and you get sine of 45 equals cosine of 45. That's if you have the angle. Class, do we have the angle here? No, we have the ratio of the side, so we cannot use cofunctions, but thank you for that idea. David? He says reciprocal identity. Which one are you thinking of? Sine equals 1 over cosecant, but remember cosecant is not secant and it's not cosecant. So we can't use that one. So no cofunctions, no reciprocal identities. Ethan. Do you know an identity that can help us find cosine given sine? Hi. Okay, Ethan, what identity? Pythagorean identity. Which Pythagorean identity did you use? Okay, you got the identity correct. There are 3 of them. We're only probably going to use one of them. Which one has sine and cosine in it?
Sine squared plus sine squared theta plus. Oh my god. Plus cosine squared theta equals 1.
Remember that sine squared theta is the same thing as sine theta squared. And cosine squared theta is cosine theta squared. With your partner, I'm going to give you 40 seconds. I want you to use the Pythagorean identity to figure out cosine. Theo, help us. What is sine of theta? 1/4. So let's put in 1/4 here. Theo, 1/4 squared? 1/16. Theo, can you look ahead? What is that 1 going to become? Correct. She recognizes that 1/1, and then you need a common denominator, so if I multiply by 16/16, 1 is equivalent to 16/16. Theo, if we subtract, what do you get? Keep going, keep going, you're on a roll. What's next? Yes? What's the square root of 16? And Theo, is it going to be plus or minus? How do you know it's plus? What does it tell you about the terminal side? And what do you know in the first quadrant? Everything is positive. So we're going to use a positive radical 15 over 4. Raise your hand if you got that. So now all I do is just take this number and just substitute it back in here. So now I have radical 15 over 4. This 2, I can make a fraction by putting it over 1. Class, multiply the numerators. Actually, you know what? Let's cross cancel. If you haven't seen this before, I'll show you why it works. So if I cross off this 2, and I cross off this 2, what number am I going to write?
1.
2. The reason why I did that is because it's really 2 times 2, right? And then you're canceling off one of the 2's here, and you're left with 1, 2. Does that make sense? Okay, so then I multiply the numerator, I get radical 15, and the denominator, I get what? 8. Sine of 2 theta, the double angle identity, or double angle of sine, the answer is radical 15 over 8. Summarize what we did here. I wrote down the double angle identity of sine because I see 2 times the angle. I have sine, but I needed to find cosine. How do I make the 2 of them work? I have to use the Pythagorean identity, solve, and then substitute back in, and you get an answer.